All right, y'all, we are back with another video. We're going to be going over 10B in this video, okay? Unit 10B. And what this is about I can find missing side lengths of triangles. That's really not it, though. It's missing side lengths of triangles using our trigonometric ratios, okay? So we're actually going to be using calculators quite a bit here. So I recommend just finding a website. If you have like a calculator at home that works for you, awesome. If not, try to find a website like desmos.com, or like the one that I've used a lot is called wolframalpha.com, where you can literally just like plug things in and make sure that you're kind of just like performing the operations correctly, okay? So a couple things to note. I'm on my calculator, and I know I've got kind of this old grimy calculator, so sorry if the dirtiness of it is distracting. But the main thing to realize is that down here, right there it says DEG, and that means degrees. Okay, and so we need to make sure our calculators are set in degrees for what we're talking about today. So we're going to jump right in. I'm going to start at the top of the note sheet. This is, again, the 10B notes. You should be able to find these on Canvas, the blank note sheet. You can follow along with your notes. You can follow along on a blank piece of paper. Either way works, okay? So the first thing we're doing here is we've got this example where we've got a triangle like this. Okay, and this triangle is going to take us through this entire first page. We have a length A. We have a right angle here. We have a length B, and we have 30 here. And then we have angle theta that's going to be off here, all right? So that angle theta and then the right angle here are going to help us identify the two important things to start, okay? And those two important things to start are that across from the right angle is our hypotenuse. So this is hypotenuse, HYP. Okay, and so now because we've defined theta as this angle rather than this angle, that's going to basically tell us how we're defining which side length is adjacent or opposite. Okay, so I'm looking at angle theta, and I'm going straight across here. That's going to be the opposite angle. Okay, so OPP, yeah, you know me. And then adjacent, right here, okay? ADJ for adjacent. Okay, and so we're going to be going back to thinking about it in ratios kind of like this, what we've got over here. So the first thing we want to do is establish sine, cosine, and tangent of the angle theta, given variables a, b, and a hypotenuse length of 30. Okay, so sine of theta, so this is kind of off to the right, sine of theta. Again, let's remember, SOHCAHTOA, sine of theta, opposite over hypotenuse. Opposite is b, so this is going to be b over, our hypotenuse length is 30. Okay, so b over 30. Okay, now let's define cosine of theta. Cosine of theta, CAH. So CAHTOA, so CAH, adjacent over hypotenuse. So adjacent is A, and hypotenuse is still 30, okay? All right, now tangent of theta is going to be our last one. And again, tangent is the only one that does not have the hypotenuse in it. It's opposite over adjacent. TOA, T-O-A. So CAHTOA, that's tangent, opposite over adjacent. So opposite is B, over adjacent is A. Okay, so now what we're going to do is we're actually given, and so the big difference between this lesson 10B versus what we've done in the last couple of lessons, everything in 10A, is we actually have an angle measurement now, and we're going to use that angle measurement with these sine, cosine, and tangent to get a decimal. And then we'll use that decimal along with our algebra skills to solve for side lengths, okay? So what I've got here now is when we go from what we just did up here down to actually having an angle for theta of 22, we're now going to be able to plug in some things. So these are going to stay the same, these ratios, but we're actually going to be able to evaluate these in our calculator, okay? So right here, what we'll do now is, should I use a different color? I don't think we need to use a different color. So I'm just going to substitute in 22 degrees here. Okay, and so now we'll substitute that in for the angle theta here, here, and here. Okay, so 22 degrees, 22 degrees, 22 degrees. And really what we've done here is that now that we're given an angle, this now becomes an equation where there's only one unknown variable. And when there's only one unknown variable, we can solve for that variable, okay? So there's only one unknown variable here, and it's B. It's the side length B. There's only one unknown variable here. It's the side length A. We're not really going to be able to make much use of this because we have two unknown variables still here, okay? Even though we can, in our calculator, find what tangent of 22 degrees is, we have b and a, so this is the one that we're going to not be using here, okay? So when I go in here, really all I'm doing is I'm taking the same thing. We haven't really changed much of what we're doing here. Where we're really going to do the magic is down here, okay? So evaluating the sine of 22 degrees, I'm going to do that in my calculator. And so I kind of do that similar to how you would find a square root and evaluate a square root in your calculator, okay? So I'm going to find sine, for me that's right here, and then I'm going to put in, let's make sure, here. Okay, so yeah, sine was right here, and then I just put in 22, and I got to make sure it's in degrees so it's reading it correctly, okay? And then I press enter, and that gives me a decimal that's about 0.375, okay? So I'm going to write that the sine of 22 degrees, and again, I'm doing this work in this box down here, sine of 22 degrees equals 0.375. And I don't want you to think too much about why it comes out exactly like this. It's kind of like a next level idea of thinking about how big the angle is and all the angles related to each other. But as long as you can do this correctly in your calculator, you're going to get a decimal, okay? And then what we're going to do is where I see sine of 22, I'm going to plug that decimal in. So now that I've got this right here, I'm basically just going to put this. So I'm going to say that equals b divided by 30. Okay, so now I can even kind of erase this. So now I've just got a regular equation. We could all totally figure out how to solve this now, given just that it's one variable divided by 30. We want to get the variable by itself, so what am I going to do? I'm going to multiply both sides by 30. Okay, so multiply by 30 there, it cancels. Multiply by 30 here. 30 times 0.375 is approximately 11.25. Okay, so this gives me 11.25 is going to be our side length B. Okay, so now I can actually even write that in here. I'll erase B and I'll put 11.25. All right, so now we're going to do the same idea here. I'm starting to lose my voice. We're going to do the same idea to find angle A using cosine. Okay, because remember, cosine uses adjacent with the hypotenuse. So we're going to be using A, which is our adjacent angle. We'll use all this right here. Okay, so we'll give this a little separation. Black marker is starting to crap out. Think we can get through the lesson? Maybe I've got another black marker here. Oh yeah, okay. We'll use that one if we need to. Emergency black marker. All right, so we're going to do something very similar to start this question. So we started the last one by finding sine of 22 was equal to about 0.375. So now what we're going to do is I'm going to do cosine of 22. So I go into my calculator and I see cosine is right there and I put 22. And again, make sure you are in degrees and not radians, okay? And that gives me about 0.927. So I'm going to take that decimal all the way out to 3 places. So I'm going to say cosine of 22. Yep, that's it for that marker. Cosine, there we go, 22 equals, and one more time, it was 0.927. 0.927. Okay, and again, don't stress too much about what this exact decimal means. That's like a next level, like math 1060 concept, where if you go that far, and again, this is like what I love the most in math, is kind of the next level stuff going on here. But for all intents and purposes with this lesson, just as long as you've done it in your calculator correctly, cosine of 22, you're going to get this decimal. That means you're doing it correctly, okay? So we also had cosine of 22 is going to be a over 30. Okay, we just found out that the cosine of 22 is 0.927. So because of that, now I can basically just write in equals a over 30. A over 30. So see how we just took this and we just created a new equation out of it. Okay, we solved the cosine of 22, 0.927. So now we don't even need to think about that anymore. We've got, almost caught it, that would have been cool. We've got 0.927 equals a over 30. So the same way we solve for b here by multiplying by 30 on both sides, we're doing the same thing here. We're going to multiply by 30, multiply by 30. And when I do that math, I'm going to get about 27.8. 27.8 equals the leftover variable a. Okay, now we can do one really cool thing here to double check our math, you guys. We're gonna go back to 10a part 1, our Pythagorean theorem, because now let's actually label this. Let's go 27.8 here. So now we have 2 legs. We have leg, leg, and we have hypotenuse right here. Okay, so now I can do a squared or leg squared plus leg squared equals hypotenuse squared. So in my calculator, that's how I'm going to double check that I did everything correctly. You guys don't need to do this, but it's always good to kind of have something to check your work with. So I'm going to do the 2 legs, so we'll go 27.8 in my calculator, squared plus 11.25 squared, and that gives me 899.4, which is about 900, okay? So I'm going to do the square root of that. So now, square root of 899, and again, we'll be a little off because of rounding, but that's okay. So I do the square root of 899 and I get basically 30, 29.98. It's essentially 30, that's our hypotenuse length, so we know we did it correctly, okay? So that's a good way to always double check your work. That's what's so nice about all this and why I love it so much is that there's always you can check your work so many different ways, and it kind of just makes everything come together in a big picture sense, at least for me. Okay. So we've got 2 more pages of notes to go over. We're going to do these 2 examples up here, and we're going to check our answer the same way we just did. Okay, so it's really one example, but we're going to be doing one with, it looks like, yeah, so actually what I really like about these is this forces us to actually think about which of these ones we need to use. This is where the next level thinking is really going to come into play here, where we need to think about what we have that is given and which trig function we need to use to find the right answer. Which is really if you end up going on and using math later on in life, that's what you do. As an engineer, you're all right, I've got this problem. What's going to be the best way to solve it? What tools am I going to need to use? You need to really be able to develop those critical thinking skills. Okay, so what we've got is this right triangle. I accidentally grabbed the wrong black marker. Let's throw that over there. We've got a right triangle. Is that the wrong one? I don't know, maybe it wasn't. Okay, and we've got little b. This is a side length. We've got 8 meters. M just means meters, and that's just a unit. Units aren't incredibly important here because we're not going to be switching back and forth between units. And then we have an angle theta of 25 degrees, okay? Our right angle here, which means this is our hypotenuse. Okay, I'm actually even going to get rid of that. I'm not going to worry about the units of M being meters. Okay, so we're trying to find B, and we have. So to go through, the first thing we should do is label our hypotenuse, our opposite, and our adjacent. Okay, so our hypotenuse is always going to be straight across. This is HYP. So because this is the angle that we're going to be using, the opposite of that angle is just straight across from it. So this is opposite, which leaves this as the adjacent line. Okay, the line segment that helps the hypotenuse create the angle, that is your adjacent, ADJ. Okay, so now what we have to think about is, given what we have an adjacent, we have our angle, and we're trying to find the opposite. That's what this is asking for, solve for B. We need to think about which of these trig functions we're going to use. So the first thing that comes to mind for me is I'm thinking that I'm not using the hypotenuse at all. Okay, so if I'm not using the hypotenuse, then I don't use sine and I don't use cosine. I'm going to have to use tangent for this one, because tangent is the one that has to do with opposite and adjacent. Okay, so now that I've identified tangent as the one that I want to use, I can start solving my problem. So I want to remember what the tangent, I won't even write the angle in yet. I'm just going to write tangent of theta equals, I'm pretty much just going to copy down what we've got here. So the ratio for tangent of the angle, theta, is going to be opposite over adjacent. Okay, and so now we can fill in the things that we have to figure out where our unknown variable is, and then we can just do our math to solve it, okay? So we have the angle theta. I'm going to fill that in as 25 degrees. And again, remember that we're in degrees. It's important that you are in degrees and you're not in radians with your calculator. Okay, we have an adjacent length. That's here. That's 8. So where I see adjacent, now I can fill in 8. Okay, so our missing variable, what we're solving for is b, and that's what's going to go in this place for opposite. So I'm going to put b here for opposite. Okay, and so now we can solve this the same exact way we did the last couple questions. So what I'm going to do is in my calculator, I'm going to start by going, let's put this back on. I'm going to start by just looking at this and saying, okay, the first thing I want to evaluate is the left side there, tangent 25 degrees. That gives me about 0.466. Okay, so tangent of 25 degrees becomes 0.466. This is the same way like in your calculator if I just had you do like the square root. Remember, this is just some operation that gives us a decimal. Tangent of 25 degrees equals 0.466. So this is all equal to that ratio of b over 8. Okay, so now this looks like a problem that we could all solve, right? So I see that I want to get b by itself. B is being divided by 8, so I should multiply 8 on both sides, and that's going to help me solve it. So I multiply both sides by 8. 8 times 0.466 gives me about 3.73. Okay, so the 8's cancel over here, and then on this side I do the math and I get 3.73. And again, this is an approximation. It's an approximation, and that's why when we go back and we double check our answer, we don't get it perfectly every time, but we do get very close, which is an indicator that we've done it correctly. Okay, so this is what we have for b, so I can write that in here now. B is now 3.73. Okay, so now we need to solve for c. And we're going to do that off to the side here. And this is where we actually have two different ways we can do it. Because solving for c is the hypotenuse up here, okay? So we've got c here. Checking my time because I got to be out of here by 5 so they don't like shut the school down on me. So c is the hypotenuse, and we have two different side lengths. So we really have two options for which we can use. We can use either sine or cosine. And whichever one we decide to use is, again, that just dictates like what numbers, which side lengths we use. So if I were to use sine, which is the opposite in the hypotenuse, if I were to use sine of 25, then I would use the number I just figured out, 3.73, and I would use the hypotenuse variable to do some math and solve for that missing length. But what I'm going to do is I'm going to use cosine, because that's where we have exactly 8. We have the decimal here, which isn't exact. We have 8 here, which is exact. So I'm going to use 8, which is adjacent. And we're trying to solve for the hypotenuse, so we're going to be using whichever trig function has to do with adjacent and hypotenuse. And that's this one, adjacent and hypotenuse. This one has opposite, so it's not that. This one has opposite, so it's not that. We're using this one in the middle, cosine, okay? So now that we've decided we're going to use cosine of 25, we can write out our equation. So cosine of 25, the ratio for cosine is adjacent over hypotenuse. So it's 8 over c. Okay, and so the real trick here, let me make sure that's showing up. Yeah, that looks pretty good. Okay, so the real trick here with this is that now, this one was an easy one-stepper because b was on top. So the trick whenever you have the variable on bottom of a fraction is you can actually just switch. I can just switch c with cosine of 25, and it's going to work out. And I'll show you kind of how that all works out here in a second. But the first thing we'll do is let's evaluate the cosine of 25 in our calculator. Okay, let's get that into a decimal. So I go cosine of 25, and again, I'm just pressing cosine here of 25, and I press enter, and I get about 0.906. Okay, so cosine of 25 becomes 0.906. This is just a decimal. That's all we care about. So that equals 8 divided by c. Okay. So what I just told you guys is that what we can do is we can take this, and the little trick, the shortcut is whenever I see it like this, really to get my variable by itself, I'm going to end up with c equals 8 over 0.906. Okay, so this is the shortcut. I'm going to show you guys how I got to this shortcut, but just realize that this is like a quick way to do it. Once you get to taking a test or doing this in real life, you can just understand that it works this way. And the reason why is because to do the math to get the variable c by itself, the first thing I need to do is get c on top of a fraction. Or in other words, I need to get it out of the bottom of a fraction. So we'll multiply both sides by c to start, okay? So I multiply by c here and here. C's cancel here, and now I'm left with c times 0.906 equals 8, okay? So c times 0.906 equals 8. So now to get c by itself, I divide by 0.906. Okay, so divide by 0.906, cancels out on the left, and on the right I have 8 divided by 0.906. So really what this all turned into is exactly what I told you guys it would here. C equals 8 divided by 0.906. So now let's evaluate that in our calculator. So I do 8 divided by 0.906, and I get 8.83. Okay, so C equals 8.83. Okay, so I can put that in for C, and now we can go back through and double check. Oh goodness, they're locking the building in 20 minutes. That's all right, we'll be able to get through, I think we can get through these pretty quick. Okay, so now we're just gonna go through and we're gonna double check our answer there. Okay, we're gonna double check using what we learned in unit 10A. So I'm gonna make sure that this squared plus this squared equals this squared. So I'm gonna do 3.73 squared plus 8 to the second power, and then I'm gonna do the square root of that. And I get about 8.83. So I did it correctly. I used the Pythagorean theorem. I did 3.73 squared plus 8 squared equals 8.83 squared, okay? So I did it all good and it checked out, it was correct, so we're in good shape, okay? So we're gonna go through a little quickly with these last ones. We've got 3 more, and this has to do with angle of elevation and angle of depression, okay? Not like the Great Depression, not like being sad. Angle of depression is this is again kind of like a little engineering term almost. Angle of depression, you talk about this with surveying, which is a thing you guys I'm sure haven't heard of before. But the only real thing you need to know here, okay, so I'm talking about these definitions, angle of depression and elevation, is these are essentially the exact same. The notes make it seem like they might not always be the same, but they are always gonna be the same, okay? So we're gonna just jump right into story problem 1. So story problem 1. Maybe I picked the wrong black marker. Okay, so a ramp has an angle of elevation of 20 degrees. So this is where we're going to explain what angle of elevation means. So let's just picture a ramp on the ground. The angle of elevation is you start here and you basically go 20 degrees up. This one's like really straightforward to think about, okay? So 20 degrees. Oh my gosh, this black marker is killing me. Let me see if I've got a better one. 0 for 2 with our black markers. I actually do have one. They're about to come kick me out. All right, it's a little different marker, but it'll work. Oh yeah, there we go. That's the black we were looking for. It's a little finer, this marker. Okay, so 20 degrees is our angle of elevation. The other bit of information we're given here is that the ramp is 1.8 meters high. So I'll just kind of give you guys a little zoomed in look. A ramp has an angle of elevation of 20 meters. I'm right here. A vertical height of 1.8. What is the length of the ramp? Okay, so the vertical height given is 1.8. The length of the ramp, I'll just give that a variable x. Okay, so now this is the ground. We can get rid of what we don't need. And now I'm thinking, okay, which trigonometric function is going to relate this number to this number? And so I need to think back to sine, cosine, tangent, opposite, adjacent, hypotenuse. So this is my hypotenuse. We know that because our right angle is here. So this is hypotenuse. And this is the angle, so I go across. That means that this number is opposite, okay? So opposite. And we don't even care about the adjacent length. Like, that's irrelevant right now. Because we have opposite and hypotenuse, so I go through here and I see, okay, sine is the one that has to do with opposite and hypotenuse. I keep pointing up there. Yeah, you guys can see that all right. Okay, so sine of the angle theta is going to equal opposite over hypotenuse. Okay, so now let's fill in what we know and figure out what variable we don't know that we need to solve for. The angle is 20 degrees. The hypotenuse is our missing variable x. The opposite side length was given, that's 1.8. That's the vertical length, the vertical height that the ramp goes up. Okay, so now we have everything we need. Let's evaluate the sine of 20 degrees in our calculator. And that gives me about 0.342. Okay, so 0.342 equals 1.8 over x. Okay, so that little trick we just learned about when the variable is on bottom, let's just apply it right now. If you missed that part, go back to the previous question where I explain it, and you'll be able to see why I can just do this little trick. I can just switch this and this, and it works out. So I end up with x equals 1.8 over 0.342. And now I can just do this in my calculator. 1.8 divided by 0.342. And that's going to give me an answer of x equals 5.26. So the ramp length is about 5.26, whatever our units were, feet, meters, I don't really remember, meters. Okay, so 5.26 meters. And this makes sense. If a ramp it got about a foot, 1.8 meters off the ground, and you went up about 20 degrees, like it makes sense that the ramp would be longer than it is tall, and that kind of jives with what we talked about in the other lessons about the hypotenuse needing to be the longest side length, okay? So we're good there. Now let's flip over to the very back, the very last part of the notes. We just have 2 more story problems, okay? And so this second one, story problem number 2. Okay, let's see if we can finish up quick so the janitors don't kill me. That's probably who was haunting me the other day when I was teaching. I kept thinking there was like a ghost. It's probably the janitors just subtly telling me to get my crap together and get out of school. Okay, so to get back on track, story problem 2, SP number 2. Let's just read it off. Suppose that the sun casts a 35-foot shadow off of a building. If the angle of depression from the sun is 40 degrees, how tall is the building? Okay, so the first thing to think about is that the shadow is 35 feet, okay? The building's gonna be here, and we're gonna have some angle here. Okay, so that angle of depression, I had to think about this for a while because I was thinking maybe that means that that's here, but it really doesn't. What it means with the angle of depression is actually that if we could draw a horizontal line here, that means that the angle is gonna be right here. So what we were given there is 40 degrees. So now to throw it all the way back to unit 1, talking about opposite interior angles, or I'm sorry, it should be alternate interior angles. If this line is parallel to this line, then that means that this angle of 40 degrees is the same as this angle right here, okay? So 40 degrees is the same exact concept as we did in the last example, okay? We've got an angle here, we have a side length here, and we want to know how tall the building is. So I'm going to put a variable x right here. And now we can get rid of all this, okay? So now I got to think to myself, all right, so this is my right angle, which it is. Hypotenuse is here. But we don't care about that at all. We weren't asked to find this length, so we don't even care. All we really care about is that the angle's here, so the opposite side length is across from it. That's x. This is opposite. The adjacent side length is going to be this one here, okay? The one that's right next to it that is not the hypotenuse. Okay, so adjacent is 35 feet. So now I'm going to look at my trig functions, sine, cosine, and tangent, and I'm going to decide which one includes opposite and adjacent. And it's this one, opposite and adjacent. It's tangent. Okay, so now what I got to do is I'm just going to write tangent of the angle theta equals opposite over adjacent. Okay, so now I can fill in what I know, and we'll have a variable for what we don't know. The angle is 40 degrees. The adjacent side length is 35. And the opposite side length is x. So x divided by 35 is tangent of 40 degrees. So now on my calculator, I can real quickly do tangent of 40. Tangent of 40 gives me about 0.834, or I guess that's 0.84. So tangent of 40 degrees is approximately 0.84. It's x over 35. So now all I have to do is multiply both sides by 35, and that will give me x as the variable by itself. Okay, so I go times 35, times 35, and 35 times 0.48 is about 29.36. So 29.36 equals x. Okay, and so what that is saying is that the building is about 29.36 feet tall. So we can just put that in right here, 29.36, okay? And all that means is that the sun is at such a weird angle that the shadow is actually longer than the building, but that can happen. Like you can see that happening in real life. That's totally cool. I threw this question out to the other math teachers just to make sure I was doing it right. I'm like 99% sure we did this one right. But if we didn't, then I'll make sure to let you guys know. Okay, so story problem number 3. That was it for number 2. We found the missing variable x, 29.36 feet. So now story problem number 3. And then we will get out of here. Oh my gosh, I've only got 10 minutes left. Gotta hustle. Okay, so story problem number 3. This is about Mark. Maybe this is Mark Dawson from 3rd period. Mark, did you fly a kite and realize that 300 feet of string are out? The angle of the string to the ground is 42.5 degrees. How high is Mark's kite above the ground? Okay, so he realizes that 300 feet of string are out. So 300 feet goes there. He realizes that the angle between the string and the ground is 42.5 feet. 42.5 degrees. Okay, and we want to know how high his kite is above the ground. So the missing variable is here, it's x. Okay, so our angle is there, which means this is opposite of the angle, OPP. And this, of course, because we have a right angle here, this is our hypotenuse, HYP. Okay, so now I need to think which trig function has to do with opposite and hypotenuse. Well, that's this one up here, sine. Okay, so I'm going to do sine, and I'm going through a little quick just because I'm about to get kicked out. So sine of the angle 42.5 equals opposite over hypotenuse. So x over 300. So I'll evaluate sine of, and you know, let's actually do this one slightly different. Let's wait till the very end to evaluate this. Okay, so let's give this like an extra little thing of brackets. And we're going to evaluate it all at once, and I'll show you that you can do it the same way. So to get x by itself, I got to multiply both sides by 300. Okay, so it cancels out over here, and now I know that x equals 300 times the sine of 42.5. So I can do it all in my calculator like that. I can do 300 times sine of 42.5. And I press enter. And that gives me 202.67. I think this was feet. So that's going to go right here, 202.67. And so this is the same way as if I would have done this first as a decimal. So sine of 42.5 would give me about 0.675. And then I multiply that by 300. And that's where I get the 202.67. Okay, so that's it for Unit 10B, you guys. We've got 2 more Unit 10 subunits, 10C and 10D. But yeah, this is like where I think it really starts to kind of get real, and we've got to start thinking outside the box a little bit to answer our questions. So if you have any issues with this video, if you have any issues with the material, with how I taught it, let me know, and we can go from there. I'll try to come up with a better way to teach it, a better way to help you guys out. So I hope you enjoyed it. I'll see you next time.